All right, lecture number 2, we're going to cover axis deviation. Now, I know I had you guys read a little bit on this. I'm just going to run through it briefly on here to give you a little bit more of a visual for it. But diving in, axis deviation tells me the overall kind of direction of the electricity in the heart. So pretty much where it's starting, the direction it's going um, towards the end. So you'll see here, this is the hexaxial reference right here. Very common kind of graphic to see. And this kind of gives me the basic, outline of which electricity can travel. So remember, in reference to here, this is where your SA node is. Okay, you've got your internodal pathways essentially. Got your AV node, you got your bundle of this there, and then you've got your bundle branches and Purkinje fibers and etc. This is the overall kind of layout. So by default, okay, on a kind of default no pathology kind of heart, I'm going to start here, and that electricity overall is going to travel in this direction, somewhere in here. Okay, now that's going to put me in a range starting from 0 and going all the way to 90 that I'm going to call normal axis right here. This is all normal axis, meaning that the electricity, the direction of the electricity can start from here and go anywhere in this range and still be considered normal. Okay. Now, outside that range, though, we have 0 to negative 30. Now, some books will say, 0 to negative 20 or whatever. That's, semantics really, but this range right here is going to be called physiological left axis deviation. So kind of opposite if you're looking at, this is the right, this is the left. Physiological left. So that keyword being physiological, meaning it's okay, it's normal, it's not really pathological that I'm looking at. So that's from 0 to negative 30. And then, use a red here, from negative 30 to negative 90, we have pathological left axis. So meaning that it is not normal for the direction of the electricity to travel this far upward, we'll say. Negative 30 to negative 90. So we're looking there at pathological left axis, and then down here, starting at 90, going up to negative 180, we've got right axis deviation. Now, there's no pathological or physiological difference here. It is just right axis deviation. It's pathological in nature. And then over on the top end, from negative, if you want to say negative 180 to positive 180 to negative 90, whatever, this is extreme right axis deviation, which means essentially that the electricity is starting from the bottom and working its way back up, is how I can think about that. Now, when would it do that kind of thing? Well, think about it. If the SA node's here, if the SA node's up top, and you have the overall electricity traveling from down there up to the SA node, what kind of things would cause that? You've got anything like ventricular beats is one of the big things that would start down here and end up here. So that's one thing to look at. And looking at axis deviation, things like hypertrophy, blocks, these kinds of things. This is what's going to change the overall direction from default. Whether I have like more muscle, so essentially like more electricity, to really simplify it, it's going to pull it in one direction or the other, or the pacemaker cells are blocked off in a certain direction. So basically, the heart has to take a detour to depolarize everything. So a lot of criteria for different diseases and things use this as a point of criteria. Like, it should be, deviating to the left or right if they have this particular condition. So it's important you know how to read and find that. So keeping that there in mind, we're going to take a look at an example, 12 lead. So often in the world of EMS, this is a very common occurrence right here, where you get to see this ECG override interpretation, meaning that the signal was too shoddy for the computer in the monitor to read it. So it's just like, I don't know what to do with it. Here it is. So and when this happens, you'll notice that you don't get any of your numbers here. You don't get your PRI, you don't get your QRS, and you also don't get your axis, right? We talked about in the last lecture there. So what do you do about it? Well, the method that we discussed, or that you read about, is a very safe go-to no matter what your 12 lead looks like. So, I'm only going to look at the limb leads. So that means my window is going to be just right here. These are the only things that I'm looking at. Lead 1, 2, 3, AVR, AVL, and AVF. Precordial leads, don't care. Not going to look at those for axis, okay? I'm only looking at these because these limb leads right here, they're the ones that are essentially they go around the side of the heart, right? If I'm looking at what these leads look at, first of all the leads are pretty much looking at the left ventricle for the most part, except for like V1 through V4, kind of the front of it. Well, V1 and V2 really just more or less the septal area, but lead 1 and AV through AVF are going to be looking down the side of the heart. And you can see here, AVF 2, AVR, and 1, these leads are looking at the direction it should be going. AVL is also kind of within that range right there. And even kind of lead 3 a little bit towards the axis there, but either way, so what we're going to do is we're going to find the most biphasic lead. So when I say this word biphasic, that means that the QRS goes up above the isoelectric line and below the isoelectric line in one beat. Okay, so for example, if we look at lead 3, right here, this QRS, if this is my isoelectric line, you see it only goes above the QRS. The isoelectric line. So not biphasic. So I'm not going to look at lead 3. AVF, same deal. I'm not going to look there. AVL, same deal. Lead 2, same deal. AVR, same deal. And then I get to lead 1. So again, I'm drawing that isoelectric line, and I see a little bit of that QRS up, a little bit of that QRS down. This is going to be my most biphasic lead right here. Lead 1 in this case. So having established that lead 1 is my most biphasic lead, what I'm going to do, or what I want to do now, is look at like each one has a complementary lead, right? So lead 1 and AVF, they're complementary. So you find that biphasic one, you go to the complementary lead, which is going to be AVF in this case, right? And I look at the direction of the QRS. If the QRS is going up, as it is in this one, meaning up above the isoelectric line, then I look on this graph right here, and the triangle that is up, so that's representing the QRS, is where I'm going to look at. This is for lead AVF. And so my degrees, my axis, is going to be about 90 degrees. So kind of right on that border of right axis degree and normal. So that's how this system is used. And like I said, each lead has a complementary one. Lead 2 and AVL, they're complementary of each other. Lead 3 and AVR, they're complementary of each other. So you imagine kind of like this big X looking thing right here. Now, if the computer, normally prints out a number, you don't really need this, right? But again, what happens when you don't have a number? What happens when you have something that looks like this? Now you'll notice here a lot of artifact in all of the leads. Okay, a lot of artifact in all the leads. So very hard to figure out or get a reliable beat on what is what. Now, but not impossible. That's the thing. So looking at here, you've got, again, don't care. Don't want to look at this for axis, right? Even though there's a lot of artifact in each one of these leads, you can still see a very prominent QRS. So like lead 2, you can see it. So we can see that in lead 3 right there. AVR, AVL, AVF, pretty prominent leads. The only one that's kind of spotty is going to be lead 1. And the reason why it's spotty is because that QRS is equally up and equally down, or about that. So it makes it less prominent. And so I'm going to determine that to be my most biphasic lead, which again, just like AVF from the last one, is going to be where I look. And so my degrees are going to be about 90. This is a skill you need to practice to get proficient with, because having these numbers memorized is kind of one of those things you're just going to have to do in order to get this skill down. Okay, so just kind of bear that in mind. This is going to take some practice, but every 12 lead in that book, you should be doing this method to practice it every time you look at it. And I will kind of point out one other thing too, especially like with this one. You'll notice here, if I am looking at lead 1 to try to interpret anything, it's pretty much a wash. Like it's too much artifact. I can't see any distinguishing waves really. So it's just kind of garbled junk. One pro tip though, if you are trying to determine where the QRSs are there P waves, this kind of thing, is on the LifePak 15 at least, each column is 1 moment in time. So lead 1, 2, and 3 are all looking at the same moment. So this QRS is the same QRS as over here, which would mean that the QRS is somewhere right here. And so, like again, this QRS is the same as this one, which means the QRS is somewhere around here. And each column kind of progresses forward a little bit in time. So AVR, AVL, AVF, that's a different moment in time. But again, same one throughout right here. Different moment in time. So V1, 2, and 3, all 1 moment in time. And then, of course, lastly, you have lead 4, 5, and 6, 1 moment of time. So just one of those things you can use, kind of a tip if you're having a hard time looking at stuff, from the rhythm. You kind of have a point of reference right there.